Hello everyone, we are learning measurement and we'll be understanding about measurement. Let us understand what is measurement. Now it is a process to find the length, size or quantity of a substance. It's a process by which we can find the length, size or quantity of a substance. And it is also a process to compare an object with a standard unit of measurement. Okay, to compare an object with a standard unit of measurement. Let us also understand why do we need measurement. Why do we need measurement? Now you can see some pictures on your screen, right? By this you'll understand why do we need measurement. These are just few examples. For proper stitching of clothes, for buying correct amount and weight of things, for knowing how warm or cold it is, right? To measure the temperature. So these are some examples to let you understand why do we need measurement. What are the physical quantities of measurement? There are 4 physical quantities of measurement: mass, length, time and temperature. Let us see some non-standard units of measurement. Okay, the first one is a hand span. I think some of you have used this hand span to measure some distance, right, using your palm. The second one is a forearm length, a cubit, which is called as 1 cubit, and I'm sure that you also must have used this to measure some distance, okay, a length of an object. This is forearm length when we use our forearm. The third is footstep, which is called as pace. And now I'm sure that you also have used this method to measure the length of a room or an area. Footstep. So these are some non-standard units of measurement. Okay. Let us understand about the SI units of measurement, the International System of Units. And a unit of measurement which has a fixed value. A unit of measurement which has a fixed value is known as standard unit of measurement. I hope you understand this, right? And the standard unit of measuring length is meter, okay, symbolized with small letter m. And the SI unit of measuring mass is kilogram. The symbol is kg in small letters. And the SI unit of measuring time is second. The symbol is small letter s. So these are some of the SI units to measure measurement. And the result of every measurement consists of 2 parts. You need to understand this, okay? The first part is a number. It can be 1, 2, 3, 4, any number, which tells us the magnitude of a measurement. Now, what is a magnitude? Magnitude refers to how great this object is, means the size or greatness of something, how big or how small it is, how high or how low it is, right? The second part is the name of the unit of measurement. Like for example, 2 kg of rice. 2 is what? It is the magnitude. 2 kg, size, right? The greatness. And kg is what? The unit of measurement. So these are the 2 parts of measurement. The table below consists of basic fundamental for base quantities along with their units. You can see on your screen the base quantity and the SI units, the name and the symbol. The first one is the length. The name of the SI unit is meter and the symbol is m. Then we have mass, kilogram, symbol is kg. Time, the name of the unit is second and symbol is s. Then we have temperature, name is Kelvin, symbol is K. Now you see here that it is capital lettered K, okay, for Kelvin. Let's see the rules to write SI units and their symbols. Rule number 1, singular form is to be used. You can see the example here, kg, not kgs, okay. Rule number 2, we should not write full stop, okay, at the end. For example, kg, we should write kg, not kg full stop. Rule number 3, one space should be there between the last digit of the number and the symbol of the unit. For example, 150 space meter. It should not be written as 150 m without a space. Okay, remember this. Rule number 4. The names of the units derived from people's name are written in small letters. For example, Joule, Newton. Okay, it is written in small letters, not using capital letters like capital N, EWTO and Newton, not this way, but with small letters. Rule number 5. The symbols of the units derived from people's name are written in capital letters. For example, capital J or capital N, representing Joule and Newton. It is not written as small j or small n. Now you understand the difference here. Okay, in the previous one, rule number 4, it was the name of the units derived from people's name are written in small letters, names. Okay, but symbols are written in capital letters. Rule number 6, the sign of degree is not written when the Kelvin scale is used. For example, 273 K Kelvin, it is not written as 273 degree Kelvin, okay, which is wrong. The correct way to write is 273 Kelvin or K. Now let us understand the prefixes used with SI units. What's the meaning of prefix? Word used before the name. Let's see the first one. Kilo is equal to 1000. For example, 1 kilometer is equal to 1000 meters. Right? The second one is a hecto, which is equal to 100. And for example, 1 hectometer is equal to 100 meters. The third one is a deca, which means 10. For example, 1 decameter is equal to 10 meter. Okay, the fourth one is a deci. Now this is a 1/10, 1 by 10. For example, 1 meter is equal to 10 decimeter. The next one is centi. Centi refers to 100th. Okay, for example, 1 meter is equal to 100 centimeters. Then we have milli, which is 1 by 1000. For example, 1 meter is equal to 1000 millimeters. Okay, so these are the prefixes and the SI units. Let's see numerical to understand it much better. The question is, the height of a person is 1.50 meter. We have to express this 1.50 meter in centimeter and millimeter. Let's see the first one. We know that 1 meter is how much? 1 meter in centimeter is 100 centimeters. So 1.5 meter would be 100 into 1.50 centimeter, right? Which is 150 centimeter. Therefore, the height of a person is 150 centimeter. So we have converted 1.50 meter to 150 centimeter. Now we have to convert to millimeter. We know that 1 meter is equal to how many millimeters? 1000 millimeters. So 1.50 meter is equal to 1000 into 1.50 meter. 1.50 meter, which is equal to 1500 millimeter, right? Therefore, the height of a person is 1500 millimeter. So this was a numerical, and I hope you have understood this. You can go back through the video and see it again to understand it much better, and keep studying and keep learning.